besides the expected value and the variance, another important feature of a random variable is a quantile. So what a quantile is? You can see mathematical definition. So a quantile of the level alpha of a random variable x is a number x alpha that is minimal of all x's such that f of x is more or equal than alpha, where this capital F is the CDF. So what is the CDF? The CDF is the probability to take value less than small x. So f of x is probability to take value less than x. So actually, the quantile of the level alpha is a minimal of all numbers such that probability to take value less than this number is more or equal than alpha. Sounds sophisticated, but this definition can be simplified if we apply it only to continuous random variables. And actually, in our course, we will be interested in quantiles only of continuously distributed random variables. That is why we can use, instead of this general definition, we can use a simplified one, simplified for continuous random variables. So for continuous ones, a quantile of the level alpha can be defined as such a number that random variable takes values less of it with probability alpha and more than it with probability 1 minus alpha. So quantile of the level alpha is such a number that your random variable with probability alpha takes values less than it, and with probability 1 minus alpha takes values more than it. So, for example, if you can say that probability that the height of the first person you meet at the street with probability 0.8 will be less than 183 centimeters, this number, 183, is the quantile of the level 0.8. Because with probability 0.8, random variable of your interest takes values less than this number, and with probability 0.2 takes values more than this number. If you measure probability not in decimal numbers between 0 and 1, but in percents, the term percentile is often used. So percentile is the same actually, so quantile and percentile are the same things, but just terminology is a little bit different. So we can say the 80th percentile or 75th percentile, or we can say the quantile of the level 0.8 or the quantile of the level 0.75. So it is just the same. So quantiles are frequently used, widely used in mathematical statistics. So we will see that we need quantiles of some random variables to construct confidence intervals, to test statistical hypotheses, and so on. So also quantiles can be applied for stochastic programming problems. So what is a stochastic programming problem? It's like mathematical programming problem. So a situation where you want to find maximum or minimum point of some function with some conditions. So you are trying to find conditional minimum or conditional maximum, but you have random variables either in the function you are minimizing or maximizing, or in conditions, or both have random variables. For example, let's say that I have a shop and I buy some goods and I sell them to my customers, and I want to earn as much money as possible doing this. And so I want to know how many goods of different kinds I am to buy. So, and this depends on the customer's demand. And customer's demand is random. So I don't know in advance how many, let's say, soap of this kind, or how many potatoes, or how many yogurts they will buy. So what can I do in such a situation when I know that some variables in my problem are random? And in this case, I cannot apply just conventional algorithms from calculus to find the maximum point of a function. So the easiest way to solve this problem is to just substitute all random variables with their mean values, with their expected values. So I can estimate, so what is the mean demand for each type of goods I'm selling. And so then I will build my business plan on this idea that the demand will be equal to mean values. Mean values I found analyzing data of the previous, let's say, year. But it is a possible situation that this plan will give me the highest average income, but probability of bankruptcy in a following year, for example, will be very high, let's say 0.9. So this strategy gives me the highest average income, but the risk of bankruptcy is 0.9 during the first year. So what does it mean? It means that if there is 100 shops identical to my shop, and all of them will apply this strategy, approximately 90 of them will go bankrupt till the end of the year, but the income of the 10 shops left will be so high that average income of all these 100 shops will be more than for any other strategy. So in this situation, I want to defend myself from this risk of bankruptcy somehow. And I say, so is there any way to do this? And there is a solution. I want, if I maximize not the average income, not the mean income, so if I won't substitute all the random variables by their expected values, by their mean average values, but if I use quantiles instead, if I say that I want to maximize the income that is guaranteed with high probability, so income that is guaranteed with probability 0.9, let's say, or 0.8. So the number such that my income won't, so that my income will exceed this number, this threshold, with probability, with high probability, with probability 0.9. And this is a quantile. So such number that a random variable exceeds this number with probability 0.9. What is this? This is a quantile of the level 0.1. This is a number such that probability to take value less than this number is 0.1 and probability to take value more than this number is 0.9. So that is how quantiles can be also applied to different mathematical programs like mathematical problems like optimization, for example. There are two more terms that are often used while talking about random variables. The first one is median. A median of a random variable is defined as the quantile of the level 1/2, the quantile of the level 0.5, so such a number that probability to take value less than this number is 1/2 and probability to take value more than this number is also 1/2. So, and the mode. Mode, for a discrete random variable, mode can be defined as the most probable value. So if we calculate probabilities for each value, for each possible value, if we find the probability to take this value, and so after this we can find the value with the highest probability. It is called the most probable value or the mode of the random variable. And for continuous random variables, mode is defined as the maximum point of its PDF. So mode, median, and mean are three different entities. Sometimes they are all equal. For some distributions, all three, mode, median, and mean values are the same. But there are distributions such that they are not the same, and you can see an example. So mode is the maximum point of the PDF. Median is such a value that with probability 1/2 random variable takes values less than it, and with probability 1/2 more than it. And mean value is an average value. So in mechanical terms, it is the center of masses of a figure, geometrical figure.